Okay, lesson 2.6, graphs of rational functions. We're going to take a look at our 2.6. Make sure you have your packet available. First thing we're going to do is rational function, remember, just means that we have a fraction. So we're going to have a fraction on the bottom. Going to want to make note that that x cannot be -5. X cannot be 4. That's going to be a big thing for our rational functions, is making sure that you understand when it's going to be undefined. End behavior for asymptotes. There's going to be three things that are happening, and you need to pay attention to the degree of the numerator and the degree of the denominator. So we're talking about, it looks like the n here will be the degree of the numerator. So if the degree on top degree over the bottom degree, this is what we're going to focus on. And in this case, they're having n is the top degree and m is the bottom degree. So if the top degree is smaller than the bottom degree, we're going to have an asymptote of y equals 0. If the degrees are equal of the top and the bottom polynomials, then we're going to simplify the coefficients. We'll take a look at an example in a moment. And if the top degree is bigger than the bottom degree, then we're going to have no horizontal asymptote. Also, this is for end behavior. We're talking in the long run. First one, the only thing we're looking at is our lead coefficients. Lead terms, excuse me. I kind of like to look at this as simplification. If I just put 3x to the 5th over 8x to the 5th, the degrees are equal. So this first one, the degrees are equal, and they kind of cancel each other out. And that's where we get an asymptote at y equals 3/8. And again, that is as we limit as the x's are going to infinity and the y's are going to negative, as the x's are going to negative infinity, this is where our asymptote will be. Next one we're looking at is going to be these guys here. If we have a larger degree on the bottom, we're going to have an asymptote of y equals 0. Again, I like to look at it as, let's simplify. 5x to the 3rd over 9x to the 5th. That simplifies to 5 over 9x squared. Every time we have 1 over x or 1 over x squared, we're always going to have an asymptote of y equals 0, because there's going to be no way that we can make the function equal 0. So that's where our asymptote will always be, when our degree on the bottom is larger. And then the last one, again, we're only talking about the lead terms. And if we're talking about 6x to the 7th over 3x to the 5th. That simplifies to 2x squared. That's not necessarily what the graph would look like, but when you're talking about the end behavior, there's no asymptotes for 2x squared. So if you have a larger degree on the top than you do on the bottom, that's where you're going to get your horizontal asymptotes. Horizontal asymptotes. Vertical asymptotes when we set the denominator equal to 0. So we just talked about the horizontals. You're going to examine those lead terms on the top and on the bottom. The next thing, vertical, we're going to set the denominator equal to 0. We've already been doing that. We already did that when we calculated domain and range. X-intercepts, you're going to set the numerator equal to 0. Set the numerator equal to 0. The denominator, you do need to pay a little bit of attention to it, but for the most part, you're looking for the zeros of the function. The zeros are going to occur when the numerator is set equal to 0. And the y-intercept is probably the easiest thing. It's the value of the function when x is equal to 0. So you're just going to plug 0 in. Plug 0 in. So there's going to be 4 things you're going to look for on these problems, and we're going to have to do everything that we can to solve for the 4 things. It says find the asymptotes of the function and then determine the x and y intercepts. The problems in your homework, of course, are going to be not in factored form. For example, this problem, if we multiply this whole thing together, it would look like what? 2x squared minus 18 over x squared plus 6x plus 5. This is what the problems are going to look like in your homework. You're going to have to factor the top and factor the bottom first, and now we can do everything. I like to do my vertical asymptotes first. Vertical totes. And that's just going to be setting the denominator equal to 0 and solving. We should be able to see that x cannot be, well, I guess in this case we're talking about the totes. X can't be -1, x can't be 5, but the totes themselves are going to be x equals -1 and x equals -5. And then we can find the horizontal totes, and that's end behavior again in the long run. You might be crossing the horizontal asymptote near the origin, but as we go out to forever, you can see it. In fact, if you graph this one, please make sure that you put an extra set of parentheses around the entirety of the bottom. Otherwise, your calculator will make a mistake. Horizontal totes. We're examining those lead coefficients. So we kind of want to look at, we got x squared here, and we have a 2, x squared here. So even if it's factored already, you can see that it's going to be 2x squared over x squared. So we are focused on this guy right here. And we simplify. So it's going to be y equals 2 in the long run. That's all that we're concerned about for the horizontal totes, because the degrees were equal. That goes back to what we talked about with those 3 different things that could happen. And then my x-intercept and y-intercept. The x-intercepts happen when the function is equal to 0. And in this case, it's going to be when the numerator is equal to 0. Again, factor everything first, because look how easy. X-intercept is x equals plus and minus 3. And then y-intercept will be, y-intercept is f of 0. So we're putting 0 in everywhere. 2 times 3 times -3 over 1 times 5. What did I do? I made that a 0 and a 0 and a 0 and a 0. Looks like it's actually easier up here, -18 over 5. So I get y-intercept is going to be equal to -18 fifths. Y equals -18 fifths. So if you spin that graph on your calculator, you'll see something that, if I remember correctly, I don't have the graphing calculator up. It should look like this, and then there's a tote, and then there's something happening like this, and then we got another one. I forget which, must be up here, where my horizontal tote in the long run is going to be 2, and then I got a vertical tote at -1 and a vertical tote at -5, and somewhere in here there's a y-intercept of -18 fifths. Kind of a crude drawing. Throw it up on the calculator, see what you can see. And we got it right. Great. I want you to do this one. Wouldn't be a bad idea for you to give it a go on your own. Again, horizontal totes. If you're, horizontal totes, I'm going to go ahead and say is you're going to simplify. I got x and then I got x squared. And if I've got x over x squared, my degree on the bottom is larger. If the degree on the bottom is larger, we always have a horizontal tote of y equals 0. And then a vertical tote is what makes the bottom 0. X is 2 and x is negative 3. And a y-intercept is going to be set the numerator. This is a y, right? So we want that to be, or excuse me, I want this to be the y-intercept is when x is 0. So it's 0 minus 1 over 0 minus 2 and 0 plus 3, which is negative 1 over negative 6, which is 1/6. So the y-intercept is 1/6. X-intercept, you're going to set the numerator equal to 0 and x equals 1. Those are the 4 things you're going to have to do for 2.6. Horizontal asymptotes, you're going to find the lead term on top and the lead term on the bottom. Vertical asymptotes, set the denominator equal to 0. X-intercepts, plug 0 in everywhere you see, or excuse me, set the numerator equal to 0. Y-intercepts, put x into x equals 0 in everywhere you see it, and then you're good.